Hello, 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 and welcome to math today, Thursday, December the 3rd. We are evaluating expressions with variables. Today we're learning a new thing and focusing on a new thing for the first time. I might have mentioned variables kind of in passing before this, but today we're really going to kind of dig in on them and take a look at them and how variables work and how variables can allow us to really create complex expressions and create expressions that can show a wide variety of things. So there's what you're going to need. There's the I cans. I'm going to read them for you. It says, I can define variable. We're going to do that on the next slide. I can write an expression from a computational sentence. Remember, that's a sentence that tells you to compute something like add 5 and 10, right? That includes a variable. So in this case, add 5 and x, right? What would that look like as an expression? And then I can evaluate an expression by substituting a value for a variable. So let's jump right into it. We've got the word wall here, there, and down at the bottom, right there, we have our word variable. Okay, and a variable in a math context says, I'm just going to read what it says right there, a letter or symbol used to stand in for an unknown value in an algebraic expression. We are kind of doing algebra, not just kind of, we are doing algebra here today. So when you have an expression like 6 plus x, right, that x is just kind of a placeholder instead of just leaving a blank space, right? Because blank spaces in math can be kind of tricky. That's why we use zeros if there's no value in a particular place for place value, right? In this case, a variable is kind of our placeholder for an unknown value, okay? And when we evaluate expressions, and actually the word evaluate should be on here, and I don't have it on here, but essentially the word evaluate, and we'll talk about it more in practice once we get to the digital whiteboard, but the word evaluate really means to substitute a value for a variable. So if you have 5 plus x, we might say, well, if x equals 9, right, then go ahead and simplify that expression, right? So you substitute in a value for your variable, so you'd put a 9 where the x is in 5 plus x, so then it becomes 5 plus 9, and then you can simplify that expression to get 14. Okay? We're going to do two things today. The first thing we're going to do is we're going to practice writing expressions where there's a variable in the computational sentence, and then we're going to look at some expressions with variables and practice evaluating or getting a value, substituting that value for our variable, and then simplifying. This will all make a lot more sense once we see it in practice. So let's go to our good friend, the digital whiteboard. Let me scoot closer here, so I can actually reach the screen. So our sentence for this, our computational sentence says, for less than the product of 17 and x. Okay, for less than the product of 17 and x. So I'll do this one to start, and then we'll try one on our own. So if we think about the product of 17 and x, right, what operation are we going to figure out? What operation are we going to use if we need to find a product, right? We're going to use multiplication. So we're going to write 17 times x, okay? And you can see here, this is why we've been using the dot in the middle as our multiplication symbol, because if we had this, 17 times x, wouldn't that get confusing? I think it would. So kind of going forward, whenever we're using variables, we're going to use the dot in the middle for our multiplication symbol. Okay, and even shorterhand is actually just being able to go 17x. That essentially means 17 times x. We're going to leave the dot in the middle there just for clarity's sake for now. As you move up in algebra, you will see that where you'll have the number next to the variable, and essentially that means to multiply. Okay, so we have 17 times x minus 4, right? Because it's 4 less than the product of 17 and x. Okay, so we have 17 times x minus 4. Do you see how we got there in terms of writing that expression, right? Do we need parentheses here? What do we think? Do we need parentheses? Now, in this case, we don't need parentheses, but it doesn't change anything to add parentheses here because we are doing multiplication first. Okay, and in our, like it says down there, or actually it's kind of over there, isn't it, where I am on the screen. But in our order of operations, we do multiplication before we subtract. So whether the parentheses are there or not, we're going to multiply first. But parentheses just make things that much more clear. So I like to use them even maybe necessarily when I don't need them, but it makes it that much clearer that, hey, we're going to multiply first, just to be 100% clear with those expectations. Okay, so that's what that looks like. Now, let's try one more, and I want you to give it a try here. Okay, this says 14 divided by the sum of r and 5. Okay, 14 divided by the sum of r and 5. So think about what operations are we going to use here. We've got divided in the sentence, but then we've also got that word sum. So think back to your word wall when you see finding the sum of something. Is that adding, subtracting, multiplying, or dividing? And then, which one goes first? Use your parentheses. Okay? Try it, try it, try it. Feel free to drop your answer in the chat when you think you have one. Okay, we know we're going to need a division symbol in there. We know we're going to need, going back to our word wall, right? The sum, that means adding. So we're going to need r plus 5. And then thinking about that 14 and dividing, is it going to be, there's kind of two options here, right? You could have something that looks like this, r plus 5 divided by 14. You could put it at the end, or 14 divided by r plus 5. Okay, which one of these, option A or option B, which one of these is the computational sentence asking us to use? Let me make my face a little smaller because it's not nearly as important as the math right now. There we go. Okay, which one of these? Good question. So the letters are there because it's an unknown. We don't know what number goes there. And really any number can go there. Right? It could be r could equal 1 in this case, or r could equal 1,000,000, right? And so the variables are there as a way, kind of as a placeholder for an unknown quantity. Okay? So going back to this original idea here, which one of these, A or B, are we needing to use here? Yeah, I see somebody said B in the chat. I tend to agree with that, right? Because we have 14 divided by the sum of r and 5. Okay? This is letter A here is the sum of r and 5 divided by 14, which, because it's division, we know that order does make a difference. So we're going to need 14 divided by r plus 5. And now I kind of gave it away in the computational sentence, but we're going to need to know the sum before we divide, right? So that means we need to put our adding in parentheses, because we want to do the adding first. And if you don't add in those parentheses, what you have is 14 divided by r, and then you add 5, which would give us a different value. Okay, it's a different expression there. So we absolutely do, in this case, need those parentheses, r plus 5 first, and then divide. Okay, so what we're going to do with this particular problem is, let's think about evaluating this. So the first step to evaluating is you're going to need to substitute a value for r. Okay, our variable in this case is the letter r. It could be any symbol. It could be a triangle. It could be, most often you're going to see letters. So for this one, why don't we try this? What if we made r equals 2? If r equals 2, how would we simplify our expression? So go ahead and erase your r, or cross out your r, and put in a 2 right there, and then simplify. Right? What we're doing here is we're evaluating. We're giving value to that variable. So what would our expression become once we put a 2 in instead of that variable, instead of that r? And I'm seeing here, yep, exactly. So we take out that r and put in a 2, because r equals 2, if r equals 2. And then we have 2 plus 5 is 7. And we have 14, keep the 14 divided by. 14 divided by 7, and that simplifies to 2. Okay? What you're going to see, in like 8th grade and beyond when you get to algebra is actually multivariable. And you'll see it actually, we'll get into it a little bit in the next couple of weeks, but if you had something like, well, actually, I won't complicate things now. Let's just focus on this. You might see something with 2 variables coming up in the next couple of weeks, but we'll get to that. And you will be fully prepared when we get there. Okay, so let's pick a different value for r. Let's reset here. Back to 14 divided by r plus 5. Okay, let's pick a different value. Let's go with r equals, I'm trying to think of something where we won't need fractions. R equals 9. Okay, now substitute substitute a 9 for the r, and then simplify. And then what do you come up with? And then using those order of operations, right? Parentheses first. Everything inside the parentheses comes first. That's why we're adding first. Then do your division. Yeah, and I'm seeing, so right, I kind of did this one on purpose. So r here, we'll substitute for a 9. So again, inside the parentheses, if you see parentheses, that's the first thing you do. 9 plus 5 equals 14, and 14 divided by 14, right? If we write it as a fraction, or 14 divided by 14, there's our equivalent of 1, right? So 14 divided by 14, and this simplifies all the way down to 1. Whoops. There we go. All the way down to 1. Okay, let's try another one. So I'm going to give you the expression, and then I'll give you the value to substitute. Okay, so go ahead and take a look at that expression. It says 21 divided by t minus 12. And notice the parentheses. So what expression, or excuse me, what operation are you going to do first? Whatever's inside the parentheses. Okay? So let's make t equal, okay, try this one. So 21 divided by t minus 12, 4, t equals, let's go with this, 19. So where that t is, put a 19 there, and then simplify it. Do your subtraction first, and then divide. So instead of t minus 12, you'd then have 19 minus 12. Starting to get some answers in the chat. Keep on working it out. We got a really good question in the chat. Why can't we just put the number in straight away? Because when we, if you're encountering, as we continue to build sort of in our algebraic thinking, what we're going to find, and we're going to find this out over the next couple of weeks, is depending on what value you give your variable, patterns are going to emerge. So you can substitute it with really any number, and it'll simplify to a different value, right? So, and being able to notice that and notice those patterns, and we're actually going to put those patterns on a graph in the next few weeks and months, okay? So this is just sort of the, I guess, really, I'm not asking you to have a full and clear grasp of the why for this lesson. It's more of being able to grasp the how of substitute the number for the variable and then solve it. Okay, so for t equals 19, minus 12, 7. 21 divided by 7. Oops, not 27, 21 divided by 7. Or 7 times what is 21? 3. Okay, and so then what you could start doing is saying, if t equals 19, and then we could make, what if it was 21, what if it was something equals x, right? And we're trying to figure out what x is. That's where we're going. Then it's 3. Then it simplifies, oops, to 3. But if we put in a different variable, our value is going to change, and then what we simplify it down to is going to change. For instance, what if we did something like, let's reset our equation here. Back to 21 divided by t minus 12. What if we change it to t equals 15? So substitute the 15 for our t. and then solve. Okay. So erase, substitute in your 15, and then solve. 15 minus 12 equals 3. 21 divided by 3 equals 7, or 3 times 7 equals 21 to check it. Okay, so if t equals 19, then it simplifies to 3. If t equals 15, then it simplifies to 7. Okay, and now we can notice a pattern and start to think about potentially a pattern here. So I'm noticing when we had a smaller or less of a value for our variable, we ended up with a larger value when we simplified. I wonder if that pattern would continue to hold true. So if we put in a variable that was less than 15, would we end up with a larger, greater answer when we simplified it? What if we did something like, let's make something of smaller variable, t equals 13. When we simplify it, is it going to be larger than 7? So when you hear the term algebra, like it can feel like this pretty big, like lofty thing that you don't learn until 8th grade. But really all it is it's finding patterns and being able to evaluate expressions. Okay, that's what we're going to be going over when we kind of start to get ready for algebra. Okay, in this case, 13 minus 12 is 1, and 21 divided by 1, anything divided by 1 is itself. So it simplifies to 21. So yeah, it is true. So far. We might be proven wrong. We only have 3 examples, so we can't be completely sure. But our current working theory is the smaller the variable, the larger our simplified value is. Let's try one more before we go. We don't have to worry about the patterns on this one. Just solve it once. Here we go. D plus D times 6. We've got 2 variables, but thankfully it's the same variable. All right, D plus D times 6. And do we really have 2 variables here? What's another way we could write D plus D? Can anyone think? If you have a number and you add itself to it, what essentially are you doing? So let's try, I'll leave that question hanging there, but let's try this. Substitute D equals 4. Substitute a 4 for both d's. So you're going to end up with 4 plus 4. All right? And then multiply by 6. And what do you get? What is your simplified answer? So don't be panicked by the presence of 2 of the same letter, right? All you do is you put a 4 here, you put a 4 here, right? D equals 4 means D is going to be a 4 every single time it shows up. Okay? Parentheses first, then multiply. And what do you come up with? So we got 4 plus 4 equals 8 times 6 equals 48. Okay, and I saw a couple of people put in the chat that this would be the same as D times 2. So let's try that to be accurate here. D times 2 times 6. Substitute in your 4. 4 times 2 is, well, that's 8, times 6, 48. So yeah, I would definitely agree that D plus D is the same as 2 times D. Okay, so on your exit ticket today, there's going to be some, first, there's going to be some computational sentences, and it's going to ask you to write an expression. And then there's going to be some expressions given and a variable given, and it's going to be up to you to substitute the variable and then solve. Okay? Good luck. Thank you so much for tuning in. Remember, drop into the math office hour as soon as I get it open, which we went a little bit long today, so it should be about 5 minutes from now. And if you have any questions or you want any extra practice problems, come see me. I will be there, and I can't wait to see you. All right. Bye, y'all.